Okay, we're going to go over some print reading basics, practice sketching fundamentals, and go over the slides for Unit 5. So let's do that now. Unit 5, Fundamentals of Drawing Practices. So the learning objective of this particular unit is to be able to understand proper and use proper techniques to make freehand sketches. So this unit is about freehand sketching, sketching lines, circles, arcs, and ellipses, which is some of the techniques that they show you in this unit, and make sketches of objects in correct proportion. So proportion is the key word here, right? You can make a sketch and it might not necessarily be to size, but if you can get things within a certain proportion so that you can at least understand, interpret from that sketch, that drawing, can get the idea of what is happening in that situation. And then be able to understand the principles of orthographic projection. Blueprint reading is being able to read documents that have been created using principles of orthographic projection. Elevations are examples of an orthographic projection. Projecting from a blueprint, for example, a floor plan. And visualization of orthographic views of objects and structures. So there's different orthographic views of different objects and structures. So this will allow you to be able to understand the relationship of orthographic projection and the different views of the object. More learning objectives are to be able to create orthographic views, right? For you, when you're sketching, understanding those principles of orthographic projection allows you to create your own views and identify the different types of building views shown in construction drawings. So a lot to learn here, because what you're learning about doing when you create your own sketching, and then when you are reading plans and building drawings and shown in construction drawings. So there's a relationship there. And identify the standard dimensions practices used in construction drawings. Standard dimensioning, right? You don't have to show dimensions for everything. You may only want to show some key dimensions. Describe the dimensioning methods used for building features on different drawing types. So, one of the things that we hope that you're going to be learning, and our objective, is that you'll be able to describe the dimensioning methods, right, used for building features on different types of drawings. So different drawings have different dimensions that are like the key dimensions that I mentioned, and being able to describe them. Technical terms. Details: electrical plans, elevations, floor plans, foundation plans, framing plans, graph paper, inclined lines, mechanical plan, and orthographic projection. These are words that you should understand, become very familiar with, and be able to know what they are, and use them, at least be able to communicate and know what they mean when being discussed. Perpendicular projectors. Plan view, plumbing plan, proportion, rise, run, section, sheathing, triangle, square method, unit method. These are more technical terms, which we will be discussing. So some actually got me interested here. Perpendicular projectors. Very technical term that I've never actually heard before, but I have an idea what they're speaking about here. Section, sheathing, triangle, square method. Are you familiar with the triangle, square method? The 3, 4, 5 method. Sketching. So you see we got a little graph paper here in the background and some type of sketch. I'm not sure if it's a plan or an elevation. You see right here this little line with a scribble through it is a break line, so something's going on over here that we're not sure about. Sketching is used by craftspeople, suppliers, architects, engineers to communicate ideas, right? Sketching is still used today. When you go to a meeting or something and you brainstorm an idea, one would briefly or quickly sketch an idea on a piece of paper to demonstrate that that we all understand what we're talking about, right? Communicate the ideas and any construction details. So these are some examples of some sketches here. You see this is a larger sheet of graph paper. You've got some, looks like a patio area, a fountain, some illustrations showing you some type of organic structure looking like, rocks that form some sort of fountain, and then actual dimensions of straight lines. So that would be 6'4", 8'4". So you can see how dimensions are illustrated on the space, 14'10". So which what I would guess would represent a patio. And then this object here with red, 24,000 BTU burner. So yeah, this is some type of burner. Not sure if it's for cooking or if it's for heating at this point. But then you can see the existing house and its location, pointing out the location of gas line. And you can see some dimensions that are being pointed out into some path of travel, an area that's the porch on the other side of the house. Oh, here they're referring to new pavers. You see this notation here, new pavers. So this little area, the 7'4", and the 2'6", and the 2'4", I'm not sure what it is, but it's showing you the location of pavers on this path of travel. Then over on this side, you can see what looks like a floor plan and elevation, different views. Here you can see which is a floor plan of something that is isometrically projected, right? You can see that the lines for this cabinetry work line up directly for the lines on this elevation view here. So it's showing you what looks like some type of mantelpiece or some sort of wall with some piece of furniture stretched out here. You can see this line here is representing this shelving here, where this wall is projecting at an angle, probably, let's see, yeah, somewhere over here is where it's projecting at an angle. A little bit beyond this shelf here too, probably up to that line. So here you can see where they're showing you dimensions in the plan view over here, and then dimensions in the elevation view. Here's another dimension, and I'm not sure if that's for a countertop, but you can see the TV on the wall, or the TV on the wall, and then this piece here which could represent the top. Yeah, because it wants you to see that there's cabinetry underneath this top here. So this is what's going on, these particular units here. this cabinet with which looks like a set of drawers, another cabinet, set of drawers, and then this larger cabinet with some shelves inside, which will probably be sliding drawers and some type of doors. And that is underneath this straight line surface here, which represents the countertop. And then again, some other sets of examples of some sketches that look more computer drawn than they are by hand, right? This looks like sketches, but it also looks like a professional sketch with grayed out areas and hatching. So although it looks like it may be done by hand, it looks more again like it'd be done by a computer in a CAD drafting situation, whereas this clearly is done by hand, although very nicely done. And this one is also, I wouldn't criticize it. This also is a pretty good sketch here, especially if it's something that's done in the field and fairly quick. That's the purpose of sketching, is to be able to do something fairly quick. So if you visit a job site and you stand at that location for 20 minutes, 30 minutes and take all these dimensions and or scribble it down and then redraw it or rewrite it, something a little bit more, then you can a little bit more comprehensive, then you can use that sketch as something to discuss and agree upon your contract for construction. These are also some sketches, right? These look very artistic, hand-drawn sketches with shading and such. But then again, so is this plan of the done with a ruler and pencil. Traditionally, blueprint drawing was done. Traditionally, this work was done with a pencil and done on paper with a ruler and or a T-square and some other drafting tools. But this sketch work is done by hand using pencil. Although it looks very technical and very clean. So some of the sketching techniques when we're talking about using a pencil is that you have sharp points on your pencils give you thin lines. Rounded points or give you heavier lines, right? Because the tip of the point is wider. Rotating the pencil slightly in your fingers to help maintain a clean point. So when you are drawing, you can spin the pencil in your hand and you're always working on kind of the sharper point of the line. As things start to get rounded over, they could round over, but you have a part of the pencil which gives the best amount of color and such, and the line is more viewable, not so scratchy. So rotating the pencil helps maintain a clean point. And you can see here, this is called a terminal point. It's just a little dot. This line here is a little series of dashed lines. And we have what we call our mechanical pencils, Draft-O-Matic. You can find these at bookstores. They're drawing instruments with specified sizes of lead. In this particular case, 0.03, 0.05, and 0.07. So this is kind of cool and convenient if you do find yourself doing a lot of hand drawing or drafting. This allows you not to have to sharpen the pencils. They always stay to a particular size line width. They don't necessarily have a point on them. You draw with them flat, holding them vertical, up and down, and they just draw a flat, wide line to the 0.3 millimeter, 0.5, or 0.7. There's actually 0.9, but that's really wide, and but although it is convenient to have. So, and as you wear out when you wear out and use up the lead, you just click the button and it extends it. But they are a little bit of an investment. So you've got your mechanical pencils or your good old classic wood pencils, right? Very similar to these. But they have some wood pencils, and in this case, these mechanical pencils that are more intended for drafting or in the construction engineering trades, because they stay sharp, they could fit in your pocket, and they're very useful tools that you'd be using quite a bit of time with. So having a set of them with different sizes and also different darknesses. You can have lead that has different grades. A softer lead would give you something more darker, and then a hard lead would give you something that's more light. So as we'll see further on what the benefits of that. So pencil leads, different diameters and hardness, like I mentioned. Softer leads for sketching, harder leads for technical drawing. So when we'll see, you don't see the box of leads, but they sell little boxes of leads, and when you talk about their hardness, softer leads have more graphite. Harder leads have less graphite with more clay. So a softer lead would mean that when I'm pushing down on the pencil at a certain, making it right, more lead comes off of because it's softer, the tip wears out more. And the softer leads allow me to make darker lines or lighter lines and have more control over shading. So that's where, you've heard of the number 2 pencil. Probably, the number 2 is right there in terms, because they're referring to the lead. So having different, and be able to practice with these different leads helps you achieve more detail in your drawings. Shading if you want. And then hard lines, they make softer, lighter lines in your drawings. So kind of maybe more for dimensions and less of the actual object line. Okay, so sketching horizontal and vertical lines. Right, you've got 2 endpoints of a line. In any kind of a drawing, you're going to take a ruler and you're going to draw a straight line, or you don't have a ruler but you're going to draw a straight line. You're going to have 2 points that you're going to locate. You're going to say, give me a line from here to here. So you're going to locate your endpoints. And then you're going to position your arm so that you can move the pencil from that point to the other point in the stroke of the wrist or a sweep of the arm. And then in this case, we're going to be sketching, it says short lines. It says short light lines. So you start off, instead of drawing one thin, darker line, you draw some shorter lines just because you're aiming for that point. And you may have to change directions. And so having these little shorter sections of the line allows you to just kind of skip a space and draw a little, like a path of travel for another path. These 2 pencils could be different pencil. This could be the hard pencil in step 3 that's drawing a lighter line. And then in step 4, you have the darker, softer pencil that connects all these lines, and you trace right over the previous line. Same thing in vertical. You locate the points. You see that's the position of travel. So you position your arm and those travel movements, and then you start drawing some lighter dashed lines to reach that point. and then you can go over in another pass and connect all of the lines, making it a solid line. And so tracing over a previously drawn line is something that's normal, right? You would draw a light line and go, yep, I like it. And then when you're ready for your final line, outlining it, you will darken. So you may do a lot of your initial sketching with one pencil that's lighter, that draws the outlines of different areas and the dimension lines and the points. And then you go over whatever you may have lightly sketched out and darken back in by tracing over those other lines with another pencil at a darker line. And although this technique is old in that we don't draft our construction documents using pencil and paper anymore, although we still can, we have tools that are more productive that allow us to do that, namely CAD. Okay? But you don't get away from sketching in your career. If anything, you don't get taught sketching, because this part, being able to sketch and on paper before you take it to the drawing board in a more formal architectural sketch or drawing or drafting, you'd still want to perform some sort of preliminary sketching or ideas or brainstorming with pencil and paper. So still these techniques, although they're not as used or valued, they still have their value, especially if you want to be a proficient builder. Being able to sketch ideas can communicate back to engineers and architects, because you as a builder have experience with how items are built and put together, and you may see a detail and say this detail is not accurate to a particular situation, and you might modify those drawings or those details. And having the skills to do that, you may still do it by hand and trace over a previously made drawing. So careers in construction, the drafter, creates construction drawings for building projects. They use computer-aided design, CAD. Now there's a new career in construction, and they may be a drafter, but the drafting is not their main career. See, drafting is all about drawing the lines and putting it on paper. But you may actually be an architect or a builder, and you may need to use drafting techniques, or your drafter is also a designer. And so they are preparing construction documents, not just necessarily drafting lines on paper. And so that's where BIM becomes business information, business modeling. Information modeling is the next level, because it's providing more information and more data. So works for the architects or the engineer. So draftspeople are like assistants to architects and engineer. But it just depends if that architect engineer uses CAD. They may use BIM, building information modeling, and if that's the case, then they're no longer using the tools that were once used in CAD. So what once replaced pencil and paper is now being replaced with what now replaces CAD, which is BIM, and that's the modeling. Instead of drawing lines, you're drawing objects, three-dimensional objects, and then those drawings can provide you building documents if you want them in their traditional blueprint format. So they may prepare drawings in 2D or 3D. Not so much 3D, but only if BIM is one of the skills. If they're using Revit instead of AutoCAD to do their drawings, then they'll be typically drawing in 2D. And then continuous education to stay technology updated. So that's where BIM comes in. Okay. So you may be a drafter, but if you want to be working for an architect or an engineer, you're going to be wanting to learn BIM techniques now. Okay, this is about sketching angles. It's important to know about angles and know a little bit of the math behind them, and what a 90-degree angle is, and that half of that 90 degree is 45, or that same 90 degree broken up into 3 pieces is 30 degrees. So a right triangle here that we see is at 90 degrees. You see the 90 degree symbol, and then the dimension line with the arrows pointing from line to line, saying that this line swoops all the way down to another line, and these two lines, the relationship to each other is 90 degrees. If I were to take this distance and swoop halfway in between the two lines, find the middle, which I would say was right here, then the halfway point between this line and this line, and draw a point through it from the center point, then I would have roughly 2 angles 45 degrees. This space here is 45 degrees, and the difference, and if you take 45 and 45 and add them up, they give you 90 degrees. So that's how you know what they represent. Why is it they're in the middle? Because it's half of 90 degrees. And if you were to take that 90 degrees and divide it into 3 parts, or a third, right? Here is a third, here's 30 degrees, here's 30 degrees, and another 30 degrees. So 3 lines that break up the 90 degrees into 3 even spaces. And should you break up one of these thirds, like the very first 30 degrees, into 2 parts, then 30 degrees cut in half is 15 degrees. So you can see, like slicing a cake and taking a knife, you can kind of see, your 3 parts, and then once you've got your 3 parts, you can take one of those 3 parts and divide it by 2. And that's where you can kind of rationalize the numbers, degrees. Now that's the sketching. Now in terms of sketching of angles, you see that you draw one line down and you draw the second line at a 90 degrees to it, then those 2 lines relationship gives you 90 degrees, right? You find a point in between, put your ruler between those 2 points and draw a line, strike through it, and then you give yourself lines. So one of the things that you can practice is drawing 2 lines as close as your eyeball will get to 90 degrees, and then finding the middle of those 2 lines and drawing a line through that, and just know that that angle is 45 degrees. And then draw 3 lines and break it up into 3 pieces of that 90 degrees. And then break up one. Just break up one of those 30 degrees into 2 parts to get 15-degree angles. Okay, that'll be some practice on how you would sketch lines at an angle to each other. There are also tools that will tell you angles, but we're just sketching angles, so we're not using tools other than just a pencil and a paper and our brain. So triangle square method is a way of sketching arcs. So you've got a triangle dash square method where you project 2 lines to an intersection. So you got step 1, step 2, you got 2 lines, and you can see that they're not finished. So you project them where they crisscross each other to an intersection. Right there is where they intersect each other. And then you're going to lay out an arc radius and a center point. So now in step 2, lay out the arc radius and the center point, which is these 2 lines here. And the center of those 2 lines, it kind of creates a square to each other, right? And it's like this center point, that intersection, and that intersection, they're like at 45 degrees to each other because these 2 are at 90 degrees. And it's the center of my desired radius. Then I construct a triangle and locate the center point. So here, I construct a triangle from those 2 points, which was the middle of that square. And I'll find the middle of that triangle, and my arc is going to swing through the center point. So I would put the little dot in between on this straight line and this intersection, like there. And that would basically be the path of travel, assuming that that was a compass point or your radius. You just swing across through that to generate that path right there. And then you just darken it and complete that radius there. And so these are the steps to getting that to be a radius from those corners. Very plain and rudimentary technique. Okay, sketching circles using the triangle square method. You'd locate a center. Okay, there's the center. You just pick a point. Okay, and then you estimate half of the diameter. So if I'm going to build a 3-inch circle, then half of the diameter is 1.5 inches. So I swing 1.5 inches one way, and I pick a little point, and from there I estimate a little point there. That's half the diameter. And so these little X marks now represent the little points, and I can draw lines through them and create this quadrant. And from the center, from the little cross to the center, is the half diameter that we've estimated. Now we'll draw a square, so we'll extend these cross lines all the way around, which gives us the section, gives us the layout of a square. And then we'll draw diagonal lines to form triangles. So from where the points intersect, we'll go from point to point, drawing triangles all the way around. You see how the lines kind of go long? Because they extend beyond the point. Because we're just sketching. So you're drawing those with light drawings. Then notice this little center point, which is going to be part of the circle of the arch. It's halfway between the line here and the point of that triangle. It's the middle. And then if I was swinging an arch here, I'd swing it from there to there, this being the center radius. And then you can trace out that line, and you can see its path is going to go through those 4 dots. So you sketch the diagonal lines to form the triangles, and then you lightly draw quarter circles. Why quarter? Because see, I got 1, 2, 3, 4 squares. And each square represents a quarter or a quadrant in this larger circle. So 1/4, 2/4. So I'm drawing quarter of a circle each time I go from one point through the center to the end point. And then when I'm happy with it, I darken it in. And I may leave these lines here just to show me where the center is and where the quadrants are. Sketching ellipse is very similar to sketching a circle, except that we have 2 different axes. when we located the half of the diameter from the center, it was the same on all four sides. But when we do that with an ellipse, it's only the same in two directions. So up and down will be a certain distance or a radius, and side to side would be a different radius. So you're able to then you can see that this major axis, the longer one, is wider than the minor axis. So the radius from this point to there, to this point to there, to there, on the bottom line is the same, whereas the major axis from the radius is longer or more separate, wider. So when you trace it out, you don't have a square, you have more like a rectangle. So an ellipse is like a circle following the pattern inside a rectangle. And you can see, assuming this is the center, you kind of sketch the path of travel of the arches from the radius, from the center where it crosses, from that center, knowing that they have to reach now over to this one. So see how they aim for each other. So you just kind of trace within that area that you've sketched out to complete that ellipse. Proportion sketching. So this is just saying that when I draw lines in relationship to each other, I want to be able to convey the idea of size relationship. Like all these four circles that are separated from each other, they're separated from a distance. They're all separated, but they're all also located in the middle of the square in this grid. And you can see that within the grid outline, it follows a pattern that creates a large rectangle that gives me squares that travel 3 squares in the vertical direction and 6 squares in the horizontal direction. And then if I take 4 circles and position them in the top, the center, and the lower rows, but in different columns, like the first column, the middle column, and the end column, and I centered them, these circles are all the same size, but their location, this one is from center to center, going 1, 2 centers away. This one is 1, 2, 3, 4 centers, square centers separated from each other, or 4 spaces. So 1, 2 separation versus 1, 2, 3, 4 separation in the other direction. Okay. So the size relationship, you see that they're all the same, but the proportion is of how they're separated between each other. You also want to try to get that right as well. So you're establishing the relationship between objects using the unit method, right? That's what these squares are. They're units. And so when I said spaces, 3 units and 5 units, 1, 2, 3, 4, 5, we're talking about these spaces or squares that we're calling units. So we got 5 in one direction, 3 in another direction. And then we start spacing them using that same concept of unit spacing. So here we've got a relationship of 3 circles located within a rectangular space that ends up being an elliptical space. So this is how you would do the finished product in 4, or the object to be sketched. You know, I see an object and now I want to trace it out onto a piece of paper so I can convey that idea back at the home shop. Well, I have an ellipse with 3 circles in it of 2 different sizes, and so I would draw the rectangle to establish where the location of the ellipse is going to go, and then I would, because the center of all of the circles and the ellipses are the same in one direction, I'll draw a center line, a horizontal line going through the rectangle, which will also be the center line of the bigger and the smaller circles. Then the other direction, I'll get the spacing right and draw vertical lines to get an idea where the centers are. So I'll get this line, the center lines of the circles, and then continue by drawing the squares to establish the size of the circle so I can complete those circles. And then finish the trace out by just leaving the locations of the center lines, and then roughly trace out the location of the ellipse, and then darken everything into its finished product there. Aids, things that help you sketching: graphing paper, straight edge rulers, or just straight edges or rulers. Developing sketching unit aids are no longer needed. Developed sketching unit aids are no longer needed. Note, making accurate sketches is a skill that takes practice. Right, I've been saying that. To improve your sketching ability, practice making sketches daily. Now that's not a bad idea. Having a Moleskine book with you with graph paper in it, or a composition book with graph paper, and being able to make sketches of views that you might see sitting around campus, for example. You can sketch any object. It does not have to be a construction detail. Do this again and again, and in time you'll be impressed with how you improve using this valuable technique. So develop sketching unit aids are no longer needed. Develop sketching until aids are no longer needed. Okay, it's just saying if you get good at sketching, then you can skip using the ruler. You can draw a straight line by hand. You can draw a pretty decent circle or a pretty decent ellipse without having to use the aids, the tools. Here's a tool, right? Drafting paper, or lined graph paper. You can see that you can use the lines to get spacings, and you can sketch them out. You can count the number of squares and assign a particular scale. You can draw to scale. Orthographic drawings are almost all construction drawings are orthographic. They're created using orthographic projection. Views projected at right angles. So we're going to see examples of that. When we say they're projected, we're going to get you to understand what it means for something to be projected. And views projected at right angles. More details can be shown. We'll begin with the front view, and we'll draw all sides to true sides or scale. Okay, so here is an example of orthographic projection. Notice the box. Imagine it a paper box, made of a solid flat piece of paper that's folded, right? So the front and the sides, the length of the box, the sides and the tops, including the bottom, are all connected like a fold-out paper box. And that's what you would see here if you were looking at the front. The sides would fold out, the left side, the right side, and then either connected to the left side or connected to the right side would be the rear. So this dotted line and this dotted line is saying that it could happen on one side, over on this side, or on the other side. And it's just saying, right, a square's got to have 4 sides to it, right? So here's 1, 2, 3, and either this is going to be number 4, or your alternate number 4 is this one, okay? And you can see that on this line here, this dark line is the folding line. So the rear would fold in at 90 degrees to each other, and this side would fold in 90 degrees to the front in one direction. The right side would fold in 90 degrees to the front. The top will fold down 90 degrees. Now when you're looking at the front, you got the top and the bottom. You also have the alternate rear. So the rear could be connected to the sides, or the rear could be connected to the top. Again, this is where they would project to. So if it was all cut out of one sheet of paper, there's only going to be one rear. And it's either going to be this one, this one, this one, or that one. Like there's only one top, there's only one bottom, there's only one left, there's only one right, there's only one front, so there's only one rear. And it's either located here, 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 or here. All those 4 possible locations that it's being projected from, you see? So understanding the concept of this box and the relationship of the sides to the front and the tops to the bottom and the alternating rear view helps you understand that each one of these particular sides is what you need to see in a drawing. When I'm looking at it from the front or the sides or the rears, from the top, from the bottom to the top, I'm looking at an elevation. When I'm looking at it from the top down, I'm looking at a plan. When I am looking at it from the bottom up, they call that a reverse plan. Because sometimes I might be imagining what the ceiling looks like if I were looking up. And they call that reverse ceiling plans. And those are usually for electric light fixtures. Okay, so another example of orthographic projection is that when you have an object, you've heard the term 3 dimensions. The reason they say something that is three dimensions is because whenever you look at it, you're only going to be able to see 3 sides of any object. And that might be the front, the side, and the top, or the front, the side, and the bottom. But you're never going to see, you might see the top, the bottom, and one side, or the top, the bottom, and the other side, but you'll never see more than 3 in any particular view. So when you have that, those faces or each side that you see can project into a flat view. So see the smaller object that has the multiple sides and shapes and cutouts. When I project it onto a flat surface from those views, again, just very similar to the box, if I were to project images onto these different sides as if they were a sheet of paper in a drawing, like we see here, we'd see that that image projects onto this side or this screen in that particular method, that view. When you look at this side facing this view, that's what you see. Or when you look at a plan or from a top view down on top of something, that's what you'd see. You'd see a rectangle with a square. You might not necessarily get the idea of the depth until you look at the side where you see that there's a return. Or here, there's a return, like this side view here and this side view here. Again, the idea of projecting now where a box folded out on all the other sides, you can see that same box, the front, that folds out to the different sides. When you have this floor plan or the top that represents the roof plan, you also have roof lines, ridges. You see these ridges that extend. So when this left side, you can see how if things were folded down and swung around, it would follow this path, and these lines would line up with that line here. And that's what these circles represent. That if you were to fold this on those lines, just like you were to fold this box, you'd see how things line up so that the ridge of the roof makes sense when you look at this particular view that shows you two different roof lines here. Or on the opposite side, which only shows you one roof line. And when you look at a particular plan, you can see that why it explains where you only have a single line for that roof line, but here you have multiple, and why they don't show up or why they do show up, and how they line up in the other direction. And when we look at a set of drawings or a set of plans, we're reading plans from a three-dimensional object orthographically projected onto flat surfaces. Okay? So this is ultimately what we want to build, but we're imagining that in our head. And even if I were to draw it, I have to draw it to scale. And if I were to change every different view, I would have to redraw it by hand. Now, thanks to computers and BIM modeling, now the relationship between having unlimited numbers of three-dimensional views becomes now a possibility, because they're directly connected. The three-dimensional view and the orthographically projected view, they're really the same object. They're just showing it to you. They're showing to you the information that you've requested to be shown on paper or printed. Plan views. They're drawings that show a view from directly above. The top view is called the plan view. One plan view for each level of the building. So if we have 2 floors, the plan view, there'd be 2 plans. And a plan basically is a section of a building 42 inches from the floor up. So floor plans show the building layout. A foundation plan shows the building's foundation below the floors usually. And foundations are located below the floors. So you may see a foundation plan that may show, or a floor plan that may show you foundation information. Or you may find foundation information on a foundation plan, and see floor plan information mixed in there. Being able to differentiate the two and understand what you're looking at, the type of plan you're looking at. Because different plans represent different sections of the building at different elevations. So a foundation plan could be at a certain elevation, and a floor plan could be at a certain elevation on the first floor. Framing plans show the layout of the structural members. So a framing plan is just going to show how things are laid out, and when there's structural members, which directions they might go. So you might see a roof for a floor framing plan that shows you the layout of the structural members, like the floor joists or the ceiling joists. An electrical plan shows you where receptacles, light fixtures, and switches would be located. A plumbing plan is going to show you where heating and air conditioning equipment and supply and waste systems are going to be located. Supply and waste meaning water, and waste meaning sewer or drainage. And then heating and circulation, right? Your HVAC, heating, ventilation, and air conditioning equipment. And a mechanical plan that shows you your HVAC. So your heating and circulating equipment would be water then in that case. Water circulating equipment, hot water. because now you have your mechanical plan, which shows your HVAC system and mechanical equipment in that sense. Here's an example of a floor plan. You can see dimensions, lots of dimension lines around the outside. You can see some notes down below telling you what's going on with this first floor plan. The scale looks like 1/8 inch scale, not real sure, too small. And then you can see the exterior lineup of the walls, and you can see some written description of window openings. This looks like a fireplace and a chimney, exterior wall, couple of windows, covered entry areas. You can see where interior, exterior covered entry and interior wall location for the main door to the front door are situated. Then the return of the wall, the framing. You see these dotted lines that are in line with these walls. They can be overhead support structures. They're definitely hidden lines because they have dashed lines. So it's an object not at the same level as these locations of the walls. So they're either overhead or down below. And then over here you can see a continuous wall that separates rooms, like the garage and the dining room, all the way around to different storage areas, laundry room, lavatory, bathroom, breakfast area, nook, kitchen, family room. So all of that information you're gathering from a floor plan. An elevation is a type of orthographic view. That exterior elevation shows the exterior features, the style of a building, doors and windows, molding, exterior finish. See, I can see doors, I can see windows, I can see the height, I can see the moldings that go around the windows, and this little ornate device that goes in the center here with sometimes the center stone or the capstone. But you can see the trim around the windows and the type of windows. Like this has grid in the glass, and these have grid in the glass. You can see this little semicircle vent, which is being described there. Here it's telling you the shingles. Here it's telling you something about this trim, this front rake. Now right now I can only see roughly, I can't get a closer image of that, but this is showing you what an elevation would look like. You can even see below what might be what's happening underground. Yeah, so this is the foundation floor for the garage that's happening on the other side. And this might be the floor for the basement that's happening underneath this lower level. So it's even showing you that what's happening underground by showing you these hidden lines. They're showing you floors at different elevations, what they call footings. So dimensioning practices, how things are dimensioned, right? We're looking at a solid masonry exterior wall. We're looking at the other side of that solid masonry exterior wall, or another type of wall. This one's different, right? This one has windows in it and a door, where this one just had a wall, an interior wall. You can see the walls are defined by this little hatching, this angular line at an angle, showing you that represents the wall. And then a plan view represents a section. So I'm cutting through the wall at 42 inches in height. So I'm going to be cutting through a window or a door. So at those particular heights in the plan, that's what I would see, is the framing of the window or the framing of the door. All this is showing me some of it, like slice half of the door and slice half of the window. A detail would give me a better accurate view, closer up view. But in terms of dimensions, it shows that in this case, this window is located within a rough opening that's 3 foot 2 inches. And it's located 5 feet to the corner. So from one side to the other rough opening, it's measured from this location of 5 foot. And then from the other side of that 3 foot is 12 foot spacing. And then 2 foot in should give a remainder of 3 foot 2. So these rough openings in this particular case are located based off of their particular size and also a distance from the corner inward. Sometimes doors can be located and this dimension could be based off a center. Instead of the side of the door, it could say from the 2 foot line, I could be 19 inches to the center. But here they're located based off of the side. But when you were to add them all up in total with the 12 feet, they should add up to 25 foot 4 inches. Okay, so this is how you would see dimensions in different segments that would add up to the total. Okay, so that's pretty much it for the presentation. Take 10 minutes, 15 minutes, and come back and get your book and go to the test your knowledge section, and let's see if we can answer these questions. So I'm going to pause. Okay, hopefully you did it within 15 minutes. So I'm going to go ahead and go through this. Let me pull up. We'll try to go through this real quick. Okay, so in the test your knowledge, I'll have it so that you can download the sheet so you don't have to tear it out of your book. Otherwise, you could just write your answers down. I'll give you something to download, a PDF to download that you can write your answers in using Bluebeam and submit that way. Okay, but these are the answers. And I may not do it for this one. I may just do it for the activities because there's quite a few activities. So write your answers in the spaces provided. It is important to have a good sketching skills in order to A, impress people with your artistic ability, B, communicate ideas, C, read prints properly, D, not waste drafting supplies, E, all of the above. I'd say the answer is B. Communicate ideas. It's important to have sketching skills to be able to communicate ideas. When sketching a horizontal line, you begin by sketching a short light lines when drawing these until these initial construction lines your eyes should focus on. So, is it A, the end point of the line, the tip of the pencil, the beginning of the line, D, your thumb, E, none of the above? The answer is A, the end point of the line. True or false? In the unit method of proportioning, the longest dimension of an object is set equal to 1 unit. The other dimensions are then estimated as fractions of that unit. That sounds wrong. The unit method is proportioning the longest dimension of an object. No, it's just setting objects equal distance and spaces in the relationship to the other. So it has nothing to do with that. True or false? The more experience you gain sketching, the more tools and aids such as rulers and graph paper you should use. That's false, right? The better you get, then you don't need graph paper. Graph paper is a way of helping you draw the straight lines or get your proportions. But you can get good at not having that, just a blank piece of paper and a pencil. True or false? The point of a pencil should be sharpened differently for different weights of lines. Yes, right? We know that a fatter tip is going to give you a wider line, and a sharp tip is going to give you a thinner line, and also not as dark. Which of the leads listed below would be used for technical drawing? 4B, 6B, H, and or all of the above. It says H. I didn't know that, but H is the hardness of the. So H would be the answer. C. Why are orthographic drawings rather than pictorial drawings used for construction? So orthographic drawings are easier to create? No, they're not that easy. Pictorial drawings are too large to fit in the drawing. That's not why. More details can be shown on orthographic drawings. Yeah, I would say so. More standards require orthographic drawings. No, there's no more standards. Pictorial drawings are more commonly used. No, pictorial. We wish we could have pictorial drawings more common, and we get that more now with BIM, but not the other way around. Back then, the pictorial drawing was something that was very hard. They call those renderings. And you needed an artist, and sometimes they'd draw one pictorial drawing or two, and then they would paint them with watercolors. Now they have BIM that will do graphic renderings and then make it look like a watercolor. All done with a computer. So the answer is C, more detail can be shown. The maximum number of orthographic views of an object. Well, 2, 3, 4. None, I guess, because you could keep showing all these different views of an object, like that the picture, like in the presentation where we saw the box, and we had the back of the box. We could see the back of the box 4 different times, right? So I could see the back of the box 4 different times. So that's 4 different views that I could see the back of the box. So there's an unlimited number of times that I could do that. Which type of drawing is taken from directly above the building? That would be the plan view. Which type of drawing shows the building as if part of it were being removed? That would be a sectional view, that if we were to slice through it. And we didn't talk much about the section. Which type of drawing is used when there isn't enough room on another drawing to illustrate something? That would be the detail. Okay, so I am running out of time here, so I'm going to end it right there. My battery's dying. So if you want the answers to this, email me and I'll send you the answer sheet. All right. Take care.